So welcome back to the second episode. We are going to look at equations and identities. And under equations, we are going to start with what we call the Russell theorem. How does it state? What does it use? What is it used for? So that's what we want to look at. If A out of B equals C out of D equals E out of F equals K, they consider now in the form of Russell theorem and the equivalent to a constant, then K equals, how can you get K? What you do here, you add the numerators together with, and again the denominators together. So what this happens is going to be A plus C plus E all over B plus D plus F. So that one is going to be our Russell theorem. That's how we do that one. And again, the Russell theorem is used, this theorem is used to determine constants, and again is used to solve the simultaneous equations. The theorem of Russell can be used to solve the simultaneous equations. Can be used to solve the simultaneous equations. Can be used to solve the simultaneous equations. Take an example. If A out of B equals C out of D equals K, comma, show that K equals A plus C out of B plus D. Hence solve the equations. Can even take an example of these equations. Solve the equations. X plus 4z out of 4 equals y plus z out of 6 again equals 3x plus y all over 5 and 4x plus 5z plus 2y equals 30. So let's look at the solution. We want to start with that one. So they have given us that if A out of B equals C out of D equals a constant, that means we are talking about the source. Show that K equals A plus C out of B plus D. So we want to start with the showing. When they talk about showing, it means just come from the left hand side, that left hand side equals the right hand side. But if it is proof, you are free to start from any side which you feel is better for you. So when we start with this, we are going to start by saying A out of B equals C out of D equals K. It means every ratio equals a constant. The first one shall say A out of B equals K. This implies that when you try to make the subject A equals KB or BK, N can say BK or KB. So also C out of D equals K. This implies that what is our C? Our C equals DK. Then from this ones we can start from, and I can use this. I can say from A plus C equals, because these are the two things which I have, when I add the two, I can say maybe 1 plus 2. So what is A? A is already a BK. We are substituting that. What is our A? Our A is already BK plus, do we know our C? Our C is already DK. So we go ahead, A plus C equals, what is common there? What is common there is a K into B plus D. So can we make K the subject? What is K? K becomes A plus C all over B plus D as required. As required. I think I've tried to see how I've come out with that one. Then we are going to move on. They say the hence. When they say hence, they mean when you have stopped, then proceed with that one without diverting to another stuff which is not right. So I want to move to that one. I want to move to that one. So we are going to start by looking at the first one, which is having in terms of the resource. You start by baptizing it. You say, let x plus 4z out of 4 equals y plus z out of 6 equals 3x plus y out of 5 equals a k. So we are going to equate every scenario to that. But since they have said the hence, that means there is no need of you to equate to that k. Why am I saying that? Because they have said the hence. What you do, you have already seen that with this k, it came out as a matter of adding the numerators and adding the denominators together. So the same story is going to happen here. We are going to add the numerators. We are going to say x plus 4z plus y plus z plus 3x plus y all over 4 plus 6 plus 5 equals the constant k, which is already here. That's why I said let those ones you can even still put it and say equals k. So from there, correct like terms, x plus 3x, you are coming out with 4x plus y plus y, you are getting 2y plus 4z plus z, you are getting 5z out of 4 plus 6, you are getting a 10. Then 10 plus that, we are getting 15 equals a k. Then we are free to cross multiply. We are getting 4x plus 2y plus 5z equals 15k. But do we know our 4x plus 2y plus 5z? It is already this one, which is given as what? As 30. So we are free to substitute and we say 30 equals 15k. So dividing so out by 15, we are coming out with k equals a 2. So from there, every stuff is equal to a k. So we are going to start now. X plus 4z out of 4 equals a k, which is a 2. Cross multiply, we are getting x plus 4z equals 8. I said this is the first equation. We also come to another stuff. It is going to be y plus z equals, we're going to say 6 times a 2 equals a 12. This is the second equation. We also come to another one, is 3x plus a y equals a 10 equals a 10. This is also the third. So after realizing these ones, these are simultaneous equations with differing variables. What we're going to do, we are going to solve these ones. We first see the equations which are related. We are going to carefully use what we call elimination method. So we are going to look at the equations which are related and which can easily be eliminated. By mere seeing here, the first one is containing x and z, and this one is only having x and z. That means one can be solved with 2. And again, 1 can be solved with this, or 2 can be solved with this because there is y. So what am I going to deal with? I'm going to say equation 2 minus 3. Equation 2 minus 3. You can say Roman 2 minus 3. We want to eliminate, our interest is to eliminate y, because y is positive. So when I deduct, what am I going to have? I'm going to have z minus x equals 12 minus 10, you are getting a 2. I can call this one equation 4. Now equation 4 is related to equation 1. That means they can be solved together. Then you will say solving Roman 1 and Roman 4 simultaneously. What was Roman 1 talking about? Roman 1 is saying x plus 4z equals 8. And what is Roman 4 talking about? Is negative 3x plus z equals 2. So we can use the elimination method. I can eliminate z. I put up 1, then down I put a 4. Then we multiply throughout. This 1 times x, we are getting x plus 4z equals 8. Then this is negative 12x plus 4z equals 8. We can subtract. The only way of eliminating z is by subtracting. So if I deduct, what am I going to get? X minus 12z, we are getting 13x. This and this we are getting a 0. 8 minus 8 we are also getting a 0. So we're dividing throughout by 13, x is 0. After getting x equals 0, you can substitute in any of these equations to obtain the value of z. I can say in Roman 4, what was Roman 4 saying? Z minus 3x equals 2. But we have already got our x as 0. So when you substitute, becomes z minus 3 into 0 equals 2. Any number times 0 remains as 0. So eventually it will remain with z equals 2. After getting z equals 2, then we are remaining with getting the value of y. Where substitute in any equation. I can substitute in equation 2 or equation 3. I'm going to say in Roman 2, we have got y plus z equals 12. But we know our z is already a 2. So I've got y plus 2 equals 12, comma, y equals 10. Conclude. Never leave your answers hanging. Remember, people are rushing to mark. So be orderly. Conclude, you say therefore x equals 0, comma, y equals 10, and z equals 2. That's why I say that the Aristotle theorem can be used to solve the simultaneous equations when you are given such kind of the numbers. So as we are going to proceed to the next examples.